Hi guys, this is Mrs. Gassler, and in this video we're going to talk about names and formulas of ionic compounds. You are going to need some Cornell paper. I chose the blank stuff because I like to write charts, and you'll also need your periodic table that has the information on the back. Okay, so let's get started. First, make sure your name, date, and class period get here, and we are going to be talking about names and formulas of ionic compounds. And our essential question, surprise, surprise, is how do I write names and formulas of ionic compounds? Now, if I'm going too fast or you need to pause, feel free to do so. I'm sure you already knew that though, right? Okay, so let's start with naming ionic compounds. These are some of my favorite things to do because I really like following rules, and so I get a good time out of this one. Okay, so the first thing that we need to know about naming an ionic compound is that the cation always comes first, and that's usually a metal. There's a few polyatomic ions that are cations, and they would come first if that's what you had. And the subscripts are used to determine the charge if needed. Now there's only one case where you need to determine the charge, and so we'll talk about that here in a minute. Okay, so I have this chart for naming ionic compounds, and it looks like this. And I've got my cations over here and my anions over here on this chart, and then I've intentionally made these a little bigger because they require a little bit more writing. And so when we talk about our cations, remember they're usually metals, unless it's one of those polyatomic ion exceptions. And the metals are all over here. They're all cations. And we have tall columns of metals, and then we have short columns of metals, and then another tall column with some metals in it, and these would be part of the shorts also. And so we're going to talk about the tall and the shorts differently because we're going to treat them differently. So the tall metals, which would be mainly these first two columns here, the tall metals, they're pretty easy. You really just have to know what their name is. And then the short metals are special because you must know the charge. If you don't know the charge of these guys, you won't be able to write an appropriate name, so we're going to have to talk about what we do with that. Now with the non-metal, with the anion, it's either a non-metal or a polyatomic ion, and you can tell if it's a polyatomic ion because it's got more than one non-metal stuck together. And it's got a special name back here on the back of your periodic table. There's a big glare there. So we've got this chart. You don't have to memorize any of the names of these guys, but you'll get to know some of them because you'll write them a whole lot of times. So if it's a non-metal, when you are dealing with the non-metals, I call them a non-metal-ide because we have to change the name of the non-metal to have "ide" at the end. We're going to change the end to IDE. So for example, oxygen becomes oxide, bromine becomes bromide. So we're changing the end to I. That's our new suffix. We have to get rid of what's there and then add, it's not oxygen-ide, it's oxide. The polyatomic ion keeps its name. It doesn't change the end, so we're only changing the end to ide sometimes. Okay, so when you have one of the tall metals, that would be over here in this column, and a non-metal, it's pretty easy. You write the name of the metal and the non-metal with "ide" at the end. Boom, done. Those are the easy ones, okay? Polyatomic ions are easy also because you write the name, if it's with a tall metal, you write the name of the metal and the name of the polyatomic ion. So also easy, no thinking. Write it, done, okay? Now if it's a short metal, we have to add in another step because if it's one of these transition metals, these guys are funky. Sometimes they can have a different number of valence electrons. They're called oxidation states, and so they can form different ions. So we need to know what ion it's forming to be able to write the name. So first we have to determine the charge of the cation. The anion we'll know because they don't change. The polyatomic ions, they don't change either, but we do need to determine the charge of the cation. That's the charge of the transition metal, the short metal, okay? Once we know the charge of the transition metal, then we'll write the name of the metal and a Roman numeral for the charge, followed by the name of the nonmetal with the end changed to "ide." And then we're going to do the same thing over here. We're going to write the name of the metal and a Roman numeral for the charge. And then just, oops, I forgot the E. And then the name of the polyatomic ion. Okay, so those are pretty easy. So I have some examples here that we're going to do, and I made them in this little box so that we could kind of follow along with what we're doing. This first one is a tall metal and a nonmetal. Sodium is right here in this tall column, and then oxygen is not a polyatomic ion. So I'm literally going to write the name of the metal, sodium, and then I'm going to write the nonmetal with "ide." Oxygen becomes oxide. Now in my room I have a poster on the wall that shows you how those metals or nonmetals become ides, so if you need to look at it you can. Let's do this other one that's pretty easy. I've got K2CO3. K is for potassium, so I'm just going to write the name of that metal, potassium. And then CO3 is a polyatomic ion. It is right there, CO3, and that is carbonate. So potassium carbonate. Those are pretty easy too, right? Okay. Now this next one's not quite so easy. Ag is for silver. So I'm going to draw it here because I've got to draw a dot diagram. Chlorine is the Cl. And so I'm going to put my electron dot structures on here. Chlorine is right here. So it's got 7 dots. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, in order for both of these guys to be happy, silver must have had a dot here to give and a dot here to give, which means it became charged with a +2. So when I write this down, I'm going to write silver 2. 2 for the charge. The 2 comes from the charge. This becomes my Roman numeral right here. And then chlorine becomes chloride. So it's not too difficult. Over here, this one's going to look a little uglier. I've got cobalt, CO, and then phosphorus, which is PO4. Now, for my polyatomic ions, I'm just going to write it real close together, and I'm going to pretend it's one thing and put dots around it. Phosphate becomes -3 when it's charged, which means it gained 3 electrons, so it must have had 5. 1, 2, 3, 4, 5. All right, that means that cobalt must have given it all 3 of those. 1, 2, 3. So cobalt gets a +3 charge. So when I write its name down, I write cobalt 3. And then PO4 is phosphate. Cobalt 3 phosphate. So depending on what you've got connected, what you do to figure out what the name is a little bit different. And so I've split it up into a chart. Hopefully that organizes the information a little bit better. Okay, so let's talk about writing the formula. I like writing formulas too because, again, I really like following rules. Okay, so the way I've got this one set up, we're going to go one step at a time and we'll look at an example while we do it, and then we'll do a slightly more difficult example, and then we'll be done. So, and I've got these in columns so that the step is next to it. So we're going to look at beryllium nitride and tin 2 sulfate. Okay. So the first thing we have to do when writing an ionic compound is determine the charge of each ion. I can't emphasize how necessary that is. That is the one thing that students forget to do when they're trying to write down a formula for an ionic compound, and that is to find the charge. So I've got beryllium, and nitride is nitrogen, so that's just an N. And so I've got 3 options for trying to figure out what these charges are. And if it's a tall metal or a nonmetal, I look at the column in the periodic table. Remember, we had lots of patterns in the periodic table, and this is just another one. So beryllium and nitrogen are actually, beryllium's a tall metal and nitrogen is a nonmetal, so I'll be doing that one. If it's a short metal, the Roman numeral is my charge. And if it's a polyatomic ion, it's in the chart on the back of the periodic table. I'm going to write P table because I'm feeling lazy. Okay. So beryllium is right here. It's in the second column, so it's got 2 valence electrons. Nitrogen is right here. It's in the 5th column, or the 15, so that means it has 5 valence electrons. So now that I know the charges, I know how much electrons are going to have to be exchanged here. So the next thing I'm going to do is I'm going to draw the model. I've got plenty of room here, so I'm going to start with my BE and my 2 dots and my N with its 5 dots. Okay, so in the objective where we're talking about the models, at this point I just have to show where the electrons are moving. So beryllium gives up this electron and this electron. That's not enough for nitrogen, so I need another beryllium. That's not enough for that beryllium, so I need another nitrogen. Then I need another beryllium. This is the point where students say, oh my God, will it ever end? Yeah, ends right there. Okay. So now I know how many of each I needed so that I would end up with 0 net charge. So this is +2, +2, +2, -3, -3. That has to all add up to equal 0. If that adds up to 0, then I've done it correctly. So then all I have to do now is write the formula. So I had 3 of the BEs, so BE3, and I had 2 of the Ns, so N2, BE3, N2, beryllium nitride. Okay. Now I don't have a polyatomic ion in this one, but if I did over here and I needed more, if there's more than 1, I have to put it in parentheses, which I think is going to happen on this one, but I can't remember. But it would look like this. If I needed PO4, but I needed 2 of them, it would look like this. So that means I have 2 of the PO4s. Okay, so let's try this again with our other example, tin 2 sulfate. Tin is SN, and sulfate is one of those polyatomic ion guys over here. Sulfate is SO4. And it gets a -2 charge, which means that it has 6 valence electrons. And that's how I was able to determine the charge here in the chart on the back of the periodic table. Tin 2, that's a Roman numeral, so that's going to be my charge, which means it's going to get 2 valence electrons here to give up. Oh, this one's a lot easier than I thought it would be. All right, so I've got tin with my 2 dots and SO4 with my 6 dots. And maybe I should have picked a different one because this electron's going to go here and this electron's going to go here. And so I really just have one of those. So I get a +2 and a -2. That equals 0. So I only need one of each of those. So I'm just going to write them next to each other. Ones are invisible. SN, SO4. Tin 2 sulfate. Okay. So that's it. That's all you do there. Writing ionic compounds, or writing the formula for ionic compounds requires a little bit more work because you have to figure out how this is an absolutely necessary step. Okay, the name doesn't tell you anything about how many there are, so you have to figure that out to be able to write the formula correctly. Okay, if you need more examples or you're not sure what to do, make sure you talk to your teacher. Thanks for watching.